Welcome back to the mathematics class here, and we are in the chapter Quadrilaterals of class 9th, and we have done example sums in the previous classes. And after we are done with example sums, now we have entered into the theorems, and this is the first theorem we are doing, which is 8.1 theorem. This is found in page number 179 in the SSC textbook. I want you to watch very carefully and understand what's going on. So a diagonal of a parallelogram divides it into two congruent triangles. This is what we need to prove. Okay, we need to prove that the diagonal of a parallelogram divides the parallelogram into two congruent triangles. So first of all, let's understand that the given diagram is a parallelogram. Okay, what is a parallelogram? A four-sided quadrilateral in which the opposite sides are parallel and equal, okay, and none of the angles are 90 degrees, is said to be a parallelogram. And then it says a diagonal. What is the meaning of diagonal? Diagonal means a line that joins the two opposite vertices. A is one vertex, C is another vertex. Now when you join a line from A to C, that line is called as diagonal. Even if you join the vertex B to vertex D, that line is also called as diagonal. But we don't want, or we are not going to draw the DB diagonal because it says a diagonal. That means one diagonal. Okay, one diagonal of a parallelogram divides it. Divides who? Divides the same parallelogram ABCD into two congruent triangles. So here, after drawing this diagonal AC, because of this diagonal AC, we can now see that there are two triangles that are formed. One is the triangle ABC and the other one is the triangle ADC. ABC and ADC. These are the two triangles that are formed. And what kind of triangles are they? They are said to be congruent triangles. What is the meaning of congruent triangle? See, congruent triangles means two triangles with respect to the sides and with respect to their angles, they both of them are equal. Okay, three angles of one triangle and three angles of the other triangle are equal, along with the three sides of one triangle equal to the three sides of the other triangle. Such triangles are said to be congruent triangles. So the triangle ABC and the triangle ADC, both of them are congruent. It means that the three sides of this ABC triangle happen to be equal to three sides of this ADC triangle, and the three angles of this ABC triangle are said to be equal to three angles of ADC triangle. And that's why they are called congruent triangles. Simply orally saying it is not enough, but we need to prove it. We need to prove it geometrically and with logical reasoning how they are equal. Okay, so watch very carefully. At first, what we will do is we will write here, draw a diagonal AC. That's the first thing to do. Now, because of this, what happens is there are two triangles formed. So in triangles ABC and ADC, in these two triangles, what is happening is three things we need to bring up or bring out and show that they both are equal between these two triangles. That too, you need to select sides as well as angles. Okay, so first of all, we will take AB, okay, equal to DC. The side AB and the side DC, these both are equal because they are opposite sides of parallelogram. Remember, by property itself, opposite sides of parallelogram are equal. That's the first thing. Second thing, what we can do is we can take the angle here, or else, instead taking AB equal to DC, what we can do is we can also take AC is equal to AC. The line AC, the diagonal, is a common side for both the triangles. So we will write here the reason as common side for both the triangles, and hence it's equal. Second thing is, there is an angle here which is the angle CAB, and there is an angle here which is the angle DCA. So I'm writing here angle CAB, which is equal to DCA. Why are they equal? It is because there are two parallel lines and there is a transversal that is cutting. Observe here carefully. Whenever there are two parallel lines, and if there is a transversal that intersects both the parallel lines, two angles are formed. One angle is over here, another angle is over here. These two angles are said to be equal because they are called as alternate angles. Okay, alternate angles. All right, the same thing we can also find over here and over here. That is, angle DAC equals to ACB. Angle DAC equals ACB. Why is it so? Again, the same thing. You see, there are two parallel lines, and if there is a transversal that intersects both of them, again there are two angles formed. Okay, let me enlarge these parallel lines so that we can understand it better. So here the line, the angle that you see here, okay, this part of angle is, two more parallel lines. This part of angle and this part of angle are obviously equal because they are also alternate angles. So there are two angles and there is one side that is expressed over here between the two triangles. So it's angle, side, angle. So we can say by angle, side, angle property, therefore triangle ABC is congruent to triangle ADC. These two triangles are said to be congruent triangles. And how did this happen? It is all because of the diagonal of the parallelogram. The diagonal AC of the parallelogram made it so. If the diagonal AC wasn't there, we would have never got those two triangles. So it is because of this AC diagonal, the parallelogram got divided into two triangles, and they are said to be congruent triangles because of the equality of sides and angles between them. Why is AC equal to AC? Because it's a common side between the two triangles. Why is angle CAB equal to DCA? Because they are alternate angles. Why is angle DAC equal to angle ACB? Again, because of alternate angles. Because of these three logical reasons, we bring the conclusion that both the triangles are congruent triangles because of the diagonal AC. Hope you have understood it. Thanks for watching.